Well, in this video, we're going to look at solving quadratic equations, and we're going to use a technique called completing the square. Now, in these problems, completing the square may or may not be the most efficient technique, but sometimes we're told to use a certain technique to demonstrate knowledge of it, and that's the case here. We're being told to use the completing the square technique, and we see we're going to do two problems. The green one on the left is a little more straightforward. The blue one on the right is more complicated, and we're going to go through both of these. Let's start with this green problem. To complete the square, let's get this constant term over on the right side. So we're going to have x squared plus 6x, leave a space, and equals 15. So now we got to figure out what number to put at the end of our expression to get a perfect square trinomial. So to do that, we'll take our middle term 6 divided by 2, which is 3, and we'll do 3 squared, which is 9. So we'll add 9 to the left side, and to keep everything equal and balanced, we'll add 9 to the right side. Okay. Well, the left side, we can call this now the quantity x plus 3 squared, and the right side we can call 24. Now we've got a perfect square written as binomial squared. Our next move is to square root both sides, and we'll get x plus 3 equals plus or minus the square root of 24. Now the square root of 24 can be broken down and simplified. So let's do a little bit of scratch work. Root 24, we'll call that root 4 times root 6, which is 2 root 6. So here goes. X plus 3 is equal to plus or minus 2 root 6. Now, to get x by itself, our next move is to subtract 3 from both sides. And that's it. You can get a decimal approximations if you want, but here are two answers. And we use the completing the square method for solving this quadratic equation. Now let's take a look at this other equation. It's going to be a little more complicated. We're going to start the same way as we did before. Now, we're going to take this constant term and bring it to the other side. So we'll have 2x squared minus 5x equals 6. We're leaving a little blank. Now you notice what's different now is the leading coefficient is 2. And we didn't have a leading coefficient of 2 in the first problem. So we're going to factor out a 2 on the left side. It's going to give us 2 times the quantity x squared minus 5 halves x. And now our job is to find what term will fill in the left side of our equation to have a perfect square trinomial. So we can use the same techniques as we used before, but now we have fractions. We're going to take half of the middle term, half of negative 5 halves. It's going to make negative 5 fourths, and we'll square. Negative 5 fourths squared, well, negative 5 fourths is 25, 4 squared is 16. So we're going to get plus 25 sixteenths. Okay, now, let me give us a little more room. Okay, now we've got a little more room. Let's continue the problem. You can see it looks like we added 25 sixteenths to each side, but we really didn't add 25 sixteenths to the left. We added 2 times 25 sixteenths, because if we were to distribute the 2, you can see that we added 2 times 25 sixteenths. So on the right side, to keep everything balanced, we're going to add 2 times 25 sixteenths. Now continuing. The left side of our equation can be written as 2 times some quantity squared. This is going to be x minus 5 fourths. That's our quantity being squared. And on the right side, we got some work to do. Let's see. 2 times 25 sixteenths. That's 25 eighths. 6 plus 25 eighths. Now to get a common denominator, let's call this 48 eighths plus 25 eighths. If you add those together, you get 73 eighths. Okay. So on the right side, we'll have 73 eighths. The next step is to divide each side by 2. We get x minus 5/4, quantity squared. Again, scratch work over here. 73/8 divided by 2. It's the same thing as 73/8 times 1/2. We get 73/16. See, the steps are exactly the same as the first problem, but it's made more complicated because of the fractions. Okay, now we will square root both sides, and we're going to get x minus 5/4 equals plus or minus the square root of 73/16. Now again, keep in mind with our scratch work over here, square root of 73/16, that's really the square root of 73 over the square root of 16, which is the square root of 73 over 4. So simplifying this, x minus 5/4 equals plus or minus root 73 over 4. Now we're going to add 5/4 to both sides, and we can say that x is 5/4 plus or minus root 73/4. And you notice that we have a common denominator. We could say then that x is 5 plus or minus root 73 all over 4. Here are two answers. If you want a decimal approximation, of course, you can use your calculator to get one. But hopefully this video is helpful. Thank you for watching. When you're ready, go on and watch the next video.